going to start now our capacity analysis. The learning objectives in this session are to calculate resource capacity in a process with one type of flow unit. We want to then identify the process bottleneck and calculate the overall process capacity. We also want to find the flow time and the flow rate of the process and calculate process utilization and utilization of the resources in the process. And finally, we want you to be able to describe the significance of the process bottleneck and of the resource utilization. Now here again, we see our skateboard flow, assembly, sand, and paint. Again, the question we posed earlier, what are you interested in here as a factory manager? We mentioned, of course, that it's interesting to know how long it takes to produce a board. But we're going to start with another critical parameter, which we will use henceforth in this course, and this is our process capacity. Process capacity means the maximum number of units that our process can produce in a given period of time. Now, how do we measure this process capacity? And here we use our process flow diagram. We have a couple of things going on here. First, we have the material entering our process, number one. If we don't have any raw material, we can't produce anything. Secondly, we've got our resources here. Our resources or activities that are being performed to transform our input into our output. Now you can easily imagine here that one resource works faster than the others. Or, if we put it this way, you can imagine that one resource is slower. And this slow stage, which we're going to call the bottleneck, limits our ability to produce skateboards. Finally, we can also consider the demand. And actually, I should circle this out here. The demand, then, little guy on a skateboard, baseball hat there. If we have no demand, then maybe we should think twice before we actually produce anything, especially in the context of lean. Now, when we talk about process capacity, we're going to be referring here to the second point. We're going to be looking at the different stages working on our line. And again, the process capacity is the maximum amount that our process can produce in a given unit of time. And as a factory manager, you care about this. You're interested in what your process capacity is, and you're also interested in how you can improve it. Now we're going to look at each of our stages, because each resource has its own capacity. So we mentioned before, we need to define the unit that's going to be processed. And what did we choose here? Well, we had a skateboard. Now, this is the product that we're producing to sell, but we could also be processing loan approvals, maybe loan approvals per month. We could be looking at orders shipped, and we're interested in the orders shipped per day, or even process students through a degree program. How many students are processed through a 4-year degree program? Now, let's say that the process time for these stations are as follows. For assembly, we're going to say we have 5 minutes per board. For sand, 4 minutes per board. And for paint, 6 minutes per board. These are our processing or activity times for each activity. Now, again, just note we don't have any inventory between the stations. That means, for example, if one station is working on a board, say sand here, the board is being sanded, assembly is not able to move any of its inventory into sand. It has to wait until sand is finished. And of course, nothing moves on to paint until the board is finished. This is a step-by-step process. You can't have any of these steps working in parallel on the same board. So here we have them, the activity times that we've mentioned before. Now, again, what are we interested in? Well, Henry Ford, he established the first assembly line in his Highland Park assembly plant in Detroit in 1913. And we said this was a breakthrough idea, but actually his idea was not so much the assembly line, but the idea of speed. His goal was to focus on the speed of the production, and the assembly line was a very effective and very visible way of doing this. You've divided the process again into specific steps, very narrow steps, where the speed, and here we have clearly the speed of the line is going to be 5 plus 4 plus 6 is going to be 15 minutes to get one of those boards out. Each of these workers can specialize in a specific set of tasks with optimized tools. They can get better as they perfect their work, and there's no time wasted switching around between different tasks, for example. So speed, or what we're going to call flow time in a minute, is a very important parameter and was one of the very important reasons for the development of the assembly line. And so if we go to some definitions, we've talked about the processing time. We're going to call that P, is the time it takes an activity to process one flow unit. And we said assembly, for example, took 5 minutes, sand 4, and paint 6. So flow time now, then the speed that we've stressed, or that Ford was interested in, is going to be 5 plus 4 plus 6 equals 15 minutes. Very important measure of our process. But now we want to talk about the capacity. And the resource capacity, or 1 over P, is going to be the maximum number of flow units that an activity, that a resource can process per unit of time. Now, we have to be a little bit careful here. For assembly, for example, we said it's 1 over P, so it's going to be 1 board per minute. So it's 5 minutes per board, so that's going to be a capacity of 1 board per minute. If we multiply this by 60 minutes per hour, minutes will cancel here, and you get, 1 board per 5 minutes. 1 board for 5 minutes. If you multiply that by 60 minutes per hour, you get 12 boards per hour as your resource capacity in boards per hour at assembly. Now, if there are multiple resources at each stage, we're calling that M. So here we have M equals 1 for each stage. But if you have multiple resources, then the resource capacity becomes M over P, because these multiple people or multiple machines are carrying out the same work, and they can do this in parallel. And finally, the overall process capacity is the minimum resource capacity in the process. As we said earlier, it is the limiting factor. It's the chain here is only as strong as its weakest link. And if we want to know how much the capacity our entire assembly has, we're going to have to look then at each individual step and find the one with the lowest capacity. And this is the concept behind a bottleneck. So let's look at the entire process for our skateboard. Here we have again, assembly, 5 minutes per board. The capacity is 1 over 5, so 1 board every 5 minutes. And in boards per hour, that's 12 boards per hour. Sand, going to be 1 over 4, and paint 1 over 6. So 1 board every 4 minutes, 1 board every 6 minutes. This is equivalent then to 15 boards per hour and 10 boards per hour. Now, what is our process capacity? Process capacity is the minimum resource capacity in our process, so we see here that paint has the minimum resource capacity with only 10 boards an hour. So we've identified our bottleneck.